day 3, which is the last day of this.
This meeting is being recorded.
Over the last 2 days, we had broad discussions touching upon many theories and practical examples on classes and its investigation. I really hope you found those content useful and interesting for your daily work. Today, we'll have discussions more in detail from Mark and Arthur about the introduction to speed estimates from skid marks and distance and time equations, which is, I guess, very technical. This would help you in understanding more about the technical terms and theory behind them. Today, the training duration would be relatively shorter than other days. So you'll be free after that, after this training, and you'll be able to, take or digest other contents as well. I would also like to announce again that we'll be issuing certificates to the participants, and I would also like to mention that we have a test after today's presentation, which is online, and Arthur will be sending the link of the test to all the participants, which needs to be completed to get the certificates. The test is not too complicated, it's not too long, it's only 7 minutes. And it's just for us to understand how much you were able to understand the content. So please try to complete the test. And also I would like to mention that if you are having any issues with, any content, please let us know and we'll answer them. And you can download the recordings as well as the presentation slides from the Google Drive link, which we will be sharing with you after this training. So yeah, that's all I wanted to say. And before moving to today's content, please feel free to ask any questions regarding yesterday's module or the first day, and then Mark and Arthur would be happy to answer them. After your questions are answered, we'll move to today's presentations. Yeah, that's all. Over to you, Mark and Arthur.
Awesome. Thanks, Ritu.
Thanks, Ritu. Yeah. Hello to everyone. I'm happy to see you again. I'm lucky because Ritu already said everything, so I would say that I'm free. I just want to refer to the test because, as Ritu mentioned, to get certificate, which is, I think, a good idea, you have to go through the test. It doesn't mean you have to pass, because the test is not about passing or not passing at all. It's rather information for us, how the content was for you. Was it too difficult or maybe not much difficult? So regardless of what grade you finish the test, you will be awarded with the certificate, but the main point is to go through the test. So in the end of today's session, I will send you an email with a link, and then you go through online. And as Ritu mentioned, application says that it will take only 7 minutes to go through the test. Some questions are only with answers yes, no, yes, no. So I hope it will be quite easy and fast test for you. And please go through the test today, because we know that if you don't do this today, then you will have some other problems, with daily jobs, so you forget it. So we decided that you have to finish that test today. Since it's 7 minutes, it's not a problem. So just a quick reminder about the test. So this is everything about the test. About today's session, you know, it's quite demanding session, because there will be a lot of mathematics. And to be honest, I'm not a mathematician, but hopefully Mark is. And he will go through a lot of equations with you in normal circumstances. Delivering this training face-to-face, in person. You will have some tasks to count the skid marks, something like that. I'm not sure that today you will have a chance to do this on your own, but I'm pretty sure that Mark will go through this together with you, and I hope also that it will be understandable for you. But as I mentioned, it's quite demanding because there is a lot of mathematics. Okay, I think it's everything from my side for that moment, and we will give you a chance to ask questions if there are any, and if not, Mark will start his part with mathematics. Okay, so do not hesitate to ask questions if you have any.
All good.
Probably there are no questions for now, so Mark, you can go ahead.
Okay.
The floor is yours.
There will be soon. Awesome. Hopefully you can see that screen. Hi, everyone. Welcome to the third and final session. This session is the one that most people usually dread because we're going to do a little bit of mathematics. If you're like me, the last time I did mathematics before starting crash investigation was back at school. So that was quite a long time for me, but we'll take our time, go through this, and at the end of the session, you will be able to calculate vehicle speeds from skid marks and understand a little bit about distance and time and velocity. So it is reasonably intense, but we will try and not hurt your brains too much. We'll try and keep it practical for you to use every day as part of crash work. I'm going to assume that everyone has access to a calculator or a smartphone. The calculator on the smartphone will be all we need for doing today's maths. So before we do anything else, let's make a start. A little bit on what we're going to talk about. Some general mathematics, the order that you complete mathematical operations in. We're going to look at distance and time and the relationship between distance, time, and vehicle speed or velocity. We're going to introduce this thing called drag factor, and then we're going to show how using drag factor we can calculate the speed from vehicle skid marks. Then we will also look at combining speed. So when a vehicle skids over different types of surfaces, and as Arthur says at the end, here's going to share a link for a test. So yeah, don't sweat it. It's not going to be too scary. All right. In the program, there is no break in here. What I will do is perhaps at 10 o'clock, we'll take a quick 5-minute stretch just to give our heads a chance to relax before we carry on with a little bit more mathematics. So yeah, the last day, intense day for maths, but you'll get some good usable information out of it, I hope. All right, basic maths. Several questions around a crash can be answered using mathematics. Some of those questions include, how fast was the car traveling? How long did it take to get there? What is the stopping distance at any speed, 50 kilometers per hour? So how long will it take the vehicle to slow down to a stop or skid to a stop at that speed? How far will I travel during my reaction time? So we're going to have a look at some of these questions and use some maths to solve them. And you will be able to solve them and give the answers that we need. Sorry, my screen has just gone crazy on me. Ugh. Where has it gone? Sorry about this, having technical issues as I do. Just trying to move something. Now, yeah, that's us. All right. For a start, let's talk about the order in which we perform mathematical calculations. The way you work an equation when you do the different parts makes a big difference to the answer. I was at school and got taught this thing called BODMAS. What it is, it tells me the order that I should do mathematics. So B for brackets, O for operation, so that can be the square root, it can be squaring an answer, cubing an answer. Then we do division, multiplication, addition, and subtraction. So we have to complete equations in this order. So we do the bracket part first, and we work our way through. Some little examples there to start with. So we're going to get straight into using calculator. And if I find my calculator, what I will do is do these calculations on this calculator on screen so you can see what I'm doing. The first problem here, we have 5 plus 5 times 2. What is the answer? If we go just from left to right, 5 plus 5 is 10. 10 times 2 is 20. We didn't use BODMAS. We just went from left to right. So let's do that same equation applying the BODMAS rule. So the first thing we do is multiplication. We've got multiplication there before addition. So 5 times 2 is 10. Now we do the addition. 10 plus 5 is 15. So the correct answer is 15, not 20. So using that BODMAS does make a big difference. The good thing is that calculators, whether you have a calculator by itself or the calculator in your phone, they apply this rule. They know BODMAS and they work that way. We'll do the next one, another exercise. Again, from left to right. So we have 5 minus 5, which is 0. 0 times 10 is 0. 0 divided by 2 is 0. So we get the answer 0 if we just go straight through from left to right. Now let's do it using BODMAS. And we have a subtraction, we have multiplication, we have division. And if we look at the order, D for division first, then multiplication, and subtraction last. So first we do our division. 10 divided by 2 is 5. Now we do multiplication. 5 times 5 equals 25. Now we do our subtraction. 5 minus 25 is minus 20. So the correct answer for that one is minus 20. Again, it just demonstrates how important applying that BODMAS is to get the correct answer. And the reason I show it is when we get to the skid speed equation, that equation has these square roots. Sorry, my mouse is playing up. We have square roots and we have brackets. So we need to know the order that we're going to do it in. Oh, this is going to be really annoying. Silly mouse. Haven't changed it. Okay. All right. Let's start with some equations around constant velocity. Now, these equations are used when a vehicle is traveling at a constant speed. It's not speeding up, it's not slowing down, it's just traveling along. Excuse me. So if I'm doing 50 kilometers per hour, I'm just traveling constantly at 50 kilometers per hour. We are going to apply scientific units. So the units for measurement and time and distance. So for these equations, distance will always be in meters, time will always be in seconds, and velocity, which is another term for speed, is in meters per second. We will talk about speed as kilometers per hour. Now, with those last two, velocity and speed, they are basically the same thing, except velocity is given in meters per second, and it can include a negative value. So we could have a velocity of -10, which means it's going backwards at 10 meters per second. Speed is just the whole number, 50 kilometers per hour, not plus or minus. So that's the main difference. We're going to do our equations using velocity. So we're always dealing in meters, seconds, and meters per second for the mathematics part. So if we're going to use velocity, we need to know how to convert kilometers per hour into meters per second, because the speedometer in your car doesn't show meters per second, it shows kilometers per hour. It's a simple little constant that we will apply. So in every hour, there are 3,600 seconds. If we want to calculate velocity, we get our speed in kilometers per hour divided by 3.6 will give us our velocity. So 50 kilometers per hour divided by 3.6 equals 13.89 meters per second. What we're doing is converting speed to velocity. And the equations themselves. So those units are the ones we're going to be using. And we have three equations. Calculate velocity. It's distance divided by time. To calculate distance, it is velocity multiplied by time. To calculate time, it is distance divided by velocity. So what these equations let us do is, if we know how fast a vehicle is going and we know how long it went that fast, we can calculate how far it traveled. So for example, a car traveling with a velocity of 10 meters per second, and it travels at that speed for 10 seconds, 10 times 10 is 100. So that vehicle will travel 100 meters in that 10 seconds. That's what we're doing with this mathematics. The triangle here is an easy way to remember the equations. So instead of trying to memorize these, just memorize the little triangle here. And what it is a way to do the equations. So if I want to calculate, sorry, I'm going to change my color. I want to calculate distance. Distance up there is velocity multiplied by time. So that vertical line means multiply. So D equals velocity times time. If I want to calculate, sorry, I need to get my eraser. If I want to calculate velocity, so velocity V equals distance divided by time. That horizontal line means divided by. So velocity equals distance divided by time. And the last one, if I want to calculate the time, I need to know distance divided by velocity will give me time. So those three equations written up there are all in that triangle. And you just remember, if they're side by side, it's multiply. If there's one above the other, it's divide. Now, I still use this triangle whenever I'm doing distance time calculations for a crash report. I draw this at the top of my page and I use it to remind me what to do. So as I say, calculate velocity, I need to know distance, I need to know time, and I just divide distance by time. So that little triangle, in English, we call it the DVT triangle. I'm not sure what it will be called in Russian, but you can call it the English version. You'll know what we're saying. So let us do some mathematics. And a little trick for you, I'll just get my phone. The calculator on your phone, hopefully you can, I don't know if you'll see this or not. Try. No, hopeless. I have my calculator turned on. With the smartphone, if you turn it 90 degrees, so it goes from being vertical to sideways, the calculator will turn into a scientific calculator. You can see it change there. We're going to use the scientific calculator for most of what we're doing today. But first, let's have a crack at the first questions. The question reads, what speed is a car traveling at? And the first one is if it travels 15 meters in 2.7 seconds. So what have we been told? We're asked for speed. And there's a trick here. For us, speed is kilometers per hour. Our equations give us velocity in meters per second. So we're going to have to do some converting. But first, let's do our mathematics. We are given distance D of 15 meters, and we're given time T of 2.7 seconds. If we look at our triangle, we are given D, we are given T, so we're going to calculate velocity. And the equation that the mathematics we do is D, our distance, 15 meters, divided by our time, which was 2.7 seconds. Gives us an answer of 5.55 meters per second. That's the velocity. So every second, that vehicle will move 5.55 meters. The question has asked for speed, so we want that in kilometers per hour. This little part here is our conversions. So velocity in meters per second is speed in kilometers per hour divided by 3.6. The reverse to calculate speed is velocity multiplied by 3.6. So I have velocity. If I now multiply by 3.6, our speed is 20 kilometers per hour. So if you are talking to a witness to a traffic crash, and the witness says that car traveled 20 meters from that tree to that tree, and it took 2 seconds. I timed it in my head. From that information, we can do a speed estimation using this equation. We will go, I'll clear this and we'll do that. So the witness says 20 meters, it's our distance, and it took 2 seconds. So divided by 2 equals 10 meters per second. To make that speed, multiply by 3.6. Tells us that that witness estimates that vehicle to be traveling at 36 kilometers per hour. It's a quick little way just to do some quick maths to see how good your witness is and give you an idea of speed involved. You would have to, of course, make the assessment on how reliable that witness was in the information they gave you, but that's one of the ways you can use it. We will do the second one now. Same question, what speed is the car traveling at if it travels 25 meters in 4.2 seconds? So once again, we're given distance and time. Let's do our division. So 25, let's clear my screen, 25 divided by 4.2 equals 5.95 meters per second. That's our velocity V. We have been asked for speed, so multiply by 3.6. And there's our speed, 21 kilometers per hour for that second part. So that's calculating speed and velocity. Let's have a look at it the other way. How long, this is a question for time, how many seconds will it take a car to travel, in the first case, 100 meters at 50 kilometers per hour? So we're trying to find time. We're given distance, we're given speed, we try to calculate time. Again, another trick question. We've been told 50 kilometers per hour. Sorry, my mouse is being a very big nuisance.
Mark, can I jump in?
Yeah, please do. I'm going to change mice.
Yeah, please move the calculator to the left because you cover the content.
Oh, careful. I'll kick it out of the way until we're ready. Sorry, didn't think of that.
Yeah, but now we cannot see your calculator.
Oh, I'll put it back when we use it.
Yeah, okay. And remember just to move it maximum to the left, but because then we see the content. And there is one remark from participants, and actually I checked with Russian translation that there are some rumors with translating, but I think it's because of the microphone that interpreter is using, and the translation is unclear sometimes. One time is very clear, sometimes it's unclear. This is just one remark.
Oh, okay.
Так, у нас перевод слышно, потому что сказали, что вроде бы что-то, какие-то помехи, да, идут с переводом. И сейчас мы пытаемся рассчитать время. Первый вопрос, который мы сейчас хотим, у нас есть расстояние 100 метров, у нас есть скорость 50 километров в час, мы хотим рассчитать время. Мы должны знать скорость, у нас есть...
Velocity, we have to convert speed. So velocity equals speed divided by 3.6. So let's bring my calculator back. It's not going to come. Oh, now it's gone huge. I'm really having trouble with mice. Apologize for this. So, first question. I might even try and make it smaller. Clear everything. Velocity. We are given speed. 50 divided by 3.6 equals 13.89 meters per second. So our velocity at 50 kilometers per hour is 13.89 meters per second. We are calculating time, so we need to do distance divided by velocity. Our distance, we are told, is 100. So let's go 100 divided by the velocity we just calculated, 13.89 meters per second equals 7.199, 7.2 seconds. So what that tells us, if you are traveling at 50 kilometers per hour, it will take you 7.2 seconds to drive the length of a football field, 100 meters. Let's do the second part. It's exactly the same process. We have a distance of 200 meters and a speed of 90 kilometers per hour. Our first step is the conversion. So 90 divided by 3.6 gives us 25 meters per second. That is the velocity. Traveling at 90 kilometers per hour, you travel 25 meters every second. So we now have velocity. Let's move my calculator again. Using our triangle, distance 200 meters divided by our velocity 25 will give us the time. I'll bring my calculator back and clear it. 200 meters divided by velocity of 25 meters per second equals 8. I've done something wrong, sorry. 200 meters divided by 25 equals 8. That's it, I did do it right. So what that tells us, at 90 kilometers per hour, it will take 8 seconds to travel 200 meters, or 8 seconds to drive the distance of 2 soccer fields. So the quicker your speed goes, the greater your distance will travel in the shorter time. The last one we'll look at is how far in distance a car will travel at certain speeds. So I'll clear my thing off and just tuck that away. First question, how far, what distance will a car travel in 5 seconds at 60 kilometers per hour? Again, we have that kilometers per hour in there. So first thing to do, convert speed to velocity. And what we do is 60 divided by 3.6. So let's just do that. Divided by 3.6. And we get 16.67 meters per second. That's our velocity. At 60 kilometers per hour, we travel 16.67 meters every second. What we've been asked to do is calculate how many meters a vehicle will travel in 5 seconds at that velocity. We're calculating distance. So to calculate distance, it is velocity multiplied by time. So let's do the maths. We know our velocity is 16.67. Our time is 5 seconds. So multiplied by 5 tells us we will travel 83.33 meters in 5 seconds at 60 kilometers per hour. So we're going to repeat that one for the last question there. In this case, we have a vehicle traveling at 100 kilometers per hour. How many meters will it travel in 10 seconds? So again, we have to do that conversion to velocity. In this case, 100 divided by 3.6. Every time I click, I'll clear my calculator. 100 divided by 3.6 equals 27.7777. So we call it 27.78. So 100 kilometers per hour, the velocity is 27.78 meters per second. Every second, it will travel 27.78 meters. Our question is how many meters will we travel in 10 seconds at that velocity? So once again, distance is velocity times time. We'll do that multiplication when my calculator comes back. We have our velocity of 27.77 times 10 equals 200 and why is that doing that? Sorry, I'm going to start again. My mouse is really causing me trouble. 8 times 10. It's 277.8 meters. So at 100 kilometers per hour, in 10 seconds, you will travel nearly 300 meters. which is a long way. And if you think back to yesterday when we talked about plans, that is what the 10-second rule is. For a crash on a 100k speed limit area, we want to start looking at our scene, taking our photographs from 277 meters back to capture that 10 seconds of drive time. If it was 50 kilometers per hour, velocity is 13.89 meters per second, times 10, 138.9 meters. So 138 meters back from the impact area, start your photograph, your walkthrough. That's the 10-second rule. So you can use that for any speed limit that you may be investigating. The other thing that we want to talk about with this distance time is the reaction time. Reaction time, what we define that as, we actually call it perception reaction time. It is the time for you to see a hazard, to recognize that it is a hazard, to consider your options, and then decide which option you're going to use. So it's a 4-step process. You're driving down the road. A child comes out onto the roadway on a push bike. So you've seen this child come out onto the road in front of you and you've recognized it's a hazard. Now you're going to think about what are my options? Do I brake? Do I swerve? Or do I just carry on because the cyclist will be gone by the time I get there? You've explored your options, you decide to brake. And at that point there, your reaction time is finished. So it's a 4-step process, like I say. Recognize see something in front of you, recognize it's a hazard, consider options, decide options. And those 4 steps, the time varies, but as a general rule, in a crash investigation situation, we apply 1.5 seconds. So basically, based on studies around the world, 1.5 seconds is a good generic perception reaction time. The important thing to remember that during that perception reaction time, your vehicle speed isn't changing. You are sitting there thinking about what am I going to do in this situation. So if you're traveling at 100 kilometers per hour at 27 meters per second, times 1.5, you will be traveling 27, 37, nearly 42, 43 meters during your reaction time. So that whole 43 meters, you're using up all of that distance thinking about what to do. If you decide to brake, you apply the brakes, you then skid. So you've got your stopping distance is your perception reaction time, your thinking time, then your action, your braking time. So, and we'll do some maths on that when we do the skid mark work shortly. But let's do it for 50 kilometers per hour. This situation is exactly the same as the question above. We have a velocity, we have a speed. We want to know how many meters we will travel in 1.5 seconds. First thing we do, change that speed into velocity. So I'll get my calculator back. Clear it. 50 kilometers per hour divided by 3.6 equals 13.89. That's our velocity for 50k. Every second, vehicle travels 13.89 meters. We now have velocity. That's been the pain. And we have time, 1.5 seconds. We want to find the distance we'll travel, so it's multiplication. Velocity multiplied by time. So 13.89 multiplied by our perception reaction time, 1.5 seconds, equals 20.8 meters. So at 50 kilometers per hour, you will travel just over 20 meters during your perception reaction time. And remember, during that 20 meters, you aren't slowing down, you aren't swerving, you're just thinking about what you're going to do to respond to the hazard. We'll do it again for 80 kilometers per hour. First thing we have to do, convert that to a velocity. So clear my screen. 80 divided by 3.6 equals 22.22 meters per second. That's our velocity. At 80 kilometers per hour, we travel 22.22 meters every second. We're doing the same equation as previously. We're trying to find distance d. The equation is velocity multiplied by time. So velocity, 22.22, time 1.5. 22.22 times 1.5, 33.3 meters. So at 80 kilometers per hour, during your perception reaction time, you will travel 33.3 meters before you even initiate what you've decided to do. So it can have a big impact on the opportunity you as a driver have to avoid a hazard. How does this relate to crash work? Situation, you're driving down the road at 50 kilometers per hour. When you are 25 meters away from a driveway, the car reverses out in front of you. So you are doing 13.89 meters per second. You're traveling at 50 kilometers per hour. The car has reversed out in front of you when you are 25 meters away. Will you have time to stop clear of that vehicle? So we first do our perception reaction time, and 50 times, there's my calculator gone. I know we just did this math, but I forgot to write it down. Right, back on it, clear it again. 13.89 times 1.5. So at 50 kilometers per hour, during our reaction time, we will travel 20 meters. The car pulled out when we were 25 meters away. So now we have only got 5 meters left to stop our vehicle from 50 kilometers per hour. And when we do our skid stuff from speed from skid, you'll learn that to stop a car from 50 kilometers per hour takes around 13 to 14 meters. So we have simply not got enough distance to stop our vehicle short of that hazard. So we're going to hit the vehicle. When we think about the liability, the criminal liability for that crash, who caused it, the car backed out when the other driver had no possible chance to avoid him. So the car that's reversed out has pulled out when the other vehicle is too close. So in New Zealand, we would be charging the driver who reversed with an offence because he hasn't given that other motorist opportunity to stop short of him. The total stopping distance at 50 kilometers per hour is the distance you travel during reaction time plus the distance you skid. So 50 Ks, 20.8 meters in reaction time, plus 13, 14 meters of skid. We are now looking at approximately 35 meters to completely stop a vehicle in a reaction situation at 50 kilometers per hour. So that tells us if anything emerges in front of that driver within 35 meters, that car is going to hit them. And that's what we can do with the mathematics that we're doing. So before we head into the skid mark stuff, are there any questions on this? We have gone through it reasonably quickly, but it's now with these equations, it is just a case of make up numbers and practice the maths. You can invent any numbers you want. Put 85 meters in 12 seconds. Make up numbers, practice doing the mathematics, because that's what locks this in. The more you do, the more confident and comfortable you will be using it. And just remember that trick, how you can apply it to crash stuff, using the first equation there to validate what a witness tells you they saw. This one here, if you're wondering how long it takes a vehicle to travel a certain distance, real life case for that, how long a pedestrian walks across the road, it takes the pedestrian 10 seconds to walk over the road. How far back will that car have to have been if it is traveling at 50 kilometers per hour to give that pedestrian time to clear the road? We can do that sort of thing with this mathematics. It can be very confusing trying to establish exactly what it is you are trying to calculate. So like I say, first thing you do when you're about to start this maths, draw that triangle at the top of your page, and then sit down and think, what do I want to know? And write that down as a question. I want to know how many seconds it takes. I want to know how far it takes. I want to know the velocity or speed of this vehicle. And it just that way sets your thinking and helps you choose which of the three equations you're going to be using. So looking at the time, from here we're going on to speed from skid marks. So let's go and take an 8-minute break. If we come back at 10 a.m, we will start on the skid stuff. Just give our heads a little break. This maths is pretty intense. So I'll see you at 10 o'clock, 10 a.m. You're still awake, Arthur? Good stuff. See you soon. Welcome back. The last little part. So, and here's where the equations start getting a little bit more interesting, but not scary. We go through step by step and all will be fine. So we're going to look at calculating vehicle speed by length of skid mark. Some things we need to know. First thing is a little bit of physics. When a vehicle is moving or anything is moving, it possesses kinetic energy, the energy of movement. And one of the laws of physics is that energy is never destroyed, it is converted to another form. When a car is skidding, it's converting that kinetic energy, that energy of movement, into heat at the friction between the tires and the road, generating that smoke and a bit of noise, the screeching sound. So we are getting energy of movement converted to heat and noise. If we know how much deceleration a car has undergone, we can calculate the speed at the start of that deceleration. So braking is slowing you down, it is decelerating the vehicle. The equation we are going to be using is, where's my pointer gone? Sorry, I'm still having mouse trouble. Try and get around that. Is this equation here. It starts life as the equation for kinetic energy. And through a series of derivations and algebra we end up with this equation here. It can look intimidating, but don't be intimidated by it. When we understand what it is, it becomes quite clear. There are symbols in here. The first one is square root. So we're going to have to use our BODMAS rules because we also have brackets. So in BODMAS, the first thing we do is brackets, then we do our operation, which will be the square root. Okay, what does this all mean? 2 is just a constant. It is used to get rid of the half in the original equation. So part of the derivation, we end up with 2. D, same as for the other equations, D is the length of skid in meters. G is a symbol for gravity. Gravity pulls things down to earth, and it is a universal global number, and the number is 9.81. So if I drop an object, it's going to accelerate at 9.81 meters per second every second. So after 1 second, it is traveling at 9.81 meters per second. After 2 seconds, it is traveling double that. After 3 seconds, it is traveling triple that. So that speed increases by 9.81 meters per second every second. The last one is the critical one, which is drag factor. Drag factor is simply a term that describes how much grip a road surface has. So a brand new piece of road with nice sharp stones may have a drag factor value of 0.8. It's compared to, say, a road covered in ice, which may have a drag factor down very close to 0. Very slippery. If you skid on ice, as you probably know, you just keep skidding. It takes a very long time to slow down. It just goes and goes. So the drag factor value just represents how much grip the surface you're skidding on has. How do we determine it? The best way is to actually carry out test skids ourselves, where we drive a car at a known speed, apply the brakes violently and suddenly, causing a skid, and we let the car skid all the way to the stop. And using another version of this equation, we calculate what the drag factor is, and we'll show you that equation at the end of this presentation. Alternate ways. I'm going to give you a chart which gives a list of different types of road surface and their typical drag factor value. What I've discovered after doing this for 30 odd years is that a typical value for most sealed roads is 0.7. So I use that value as an initial assessment to tell me if there is speed involved in this collision. Is there excessive speed? If there is excessive speed, I will then conduct skid tests to get an accurate drag factor. But 0.7 is a good value to give you a good, very close estimate of the vehicle speed. So we will be using this value a fair bit today. This is the chart I was talking about, and it just gives different types of surface. So we have, it's an American source chart. So in America, they have a lot of concrete roads. Portland cement is concrete. A new sharp road, value of 0.8 to 1.2. One that's been traveled on, so a road that is a couple of years old, 0.6 to 0.8. New Zealand, we have a lot of asphalt and tar. A new one, same value as a concrete. A travelled road, so a few years old, 0.6 to 0.7. And if you think about the average of those two, 0.6 to 0.8. The average of those two is 0.7, that value that I just mentioned. So that chart can be a reference for you, but for your initial mathematics, use 0.7 for a dry road. If it is a wet road, you can look at a value of 0.55. So 2 numbers to remember, 0.7 dry, 0.55 wet. That will give you good initial approximations for speed estimates. Okay. All right, let's get scary. Let's do the maths. Here we have a situation. A car has skidded, leaving 23.5 meters of skid mark. We are going to find out how fast that car is traveling at the start of the skid mark. An important thing with this equation, it is based on a vehicle skidding all the way to the stop. So it starts at whatever speed, skids and stops. So it is the slide to stop or skid to stop equation. If we have a look at the equation, V is the symbol for velocity. So we are calculating vehicle velocity, meters per second. What do we need to know? We need to know D, the distance, the length of the skid. We are told that it is 23.5 meters. We need to know gravity. That's always 9.81. So we know that. And we need to know the drag factor. And in this case here, we're told the drag factor is 0.7. So we now have values for all of the symbols in this equation. And what we're going to do is replace the letters or the symbols with the numbers. So now we have 2 times our distance, 23.5, times gravity, 9.81, times our drag factor, 0.7. We do the stuff inside the brackets first. If we do 2 times, well, actually get my calculator, let's do it. You guys have probably raced ahead because you know where it's going. Sorry, I've lost my calculator. Come back. Here we are. Okay. 2 times our skid length, 23.5, times gravity, always 9.81, times our drag factor, 0.7, equals 322.749, or 322.75 when rounded. We have to take the square root to get our velocity. So let's find the square root symbol.
Mark, please move your calculator to the right.
Sorry, yep.
Perfect.
So the square root of 322.75 is 17.965, or 2 decimal places, 17.97 meters per second. That's velocity. We want speed, so we multiply by 3.6. So let's just do that. It's equals 64 kilometers per hour. Now just notice the when you do the maths, you will get decimal points with lots of numbers after it. So 64.67 and all sorts. For speed, we ignore all of that. Speedo in a car doesn't say you're traveling at 50.7 kilometers per hour. It tells you you're traveling at 50. So we only look at the whole number. So the number to the left of the decimal point is what we record for speed. Don't worry about the decimal point stuff after the decimal point for speed. Important for velocity, because with velocity we are dealing in smaller units and the decimal places are important for our precision and our accuracy. But the last step where we convert back to kilometers per hour, we just talk in whole numbers. So by doing that maths, you've just calculated that this vehicle at the start of that skid was traveling at 64 kilometers per hour. And that's all there is to it. The equation, as I say, can look a little bit intimidating, but when you know what the symbols mean and do the multiplication and the square rooting, the answer comes out just like that. So practice makes perfect. We'll do some more. And I do invite you to work along with these as we go. So let's just get some questions up. So I have 3 examples here. Same situation. A vehicle has skidded to a stop. We are given our skid length, our distance D in each case. So we have a skid of 17 meters, of 37 meters, and of 13 meters. We're also supplied with our drag factor F. So now we know everything we need to know to apply the equation. So let's do some working through of the first one. I'll just clear my calculator again. These calculators in your phone will be the same, are quite clever. So we can go, let's do the first one. The equation is 2 multiplied by or times D, our distance, 17 meters. In this case, 17. Just move it out the way of it for you. Multiplied by gravity, the G, always 9.81. Multiplied by the last part, drag factor F. And we are told it is 0.55 times 0.55 equals 183.447. So the part under the brackets for the first example is 183.447. To get velocity, we now have to take the square root. So we push the square root button, and our answer is 13.54 meters per second. Remember, this equation calculates velocity. We want to know speed, or kilometers per hour. Multiply that answer by 3.6. So let's just multiply by 3.6 equals 48 kilometers per hour. We only want the whole number, not all the decimal parts. And let's check, yes, the first one is 48 kilometers per hour. Okay, so that's the process. Let's repeat it for the second one. What are we given? Yeah.
Mark, there is one question.
Oh, cool.
And the question is, what is the error in applying this formula?
What is the error?
Error, yeah.
Like anything, the formula will only give you results based on how good the information you put into it is. So the source of error is accuracy of measurement of your skid. So having precise measurements and the accuracy of your drag factor. Now, just be aware, this equation will give you a speed correct to within 1 or 2 kilometers per hour. The other thing to remember with it is the speed at the start of visible skidding. You can only measure what you see. From the videos, we saw that when a car brakes, there is a short distance where the vehicle, the tire is locked but isn't leaving the mark. So with this equation, we are actually slightly underestimating speed. So our calculated speed is fractionally less. It might be half a kilometer per hour, quarter of a kilometer per hour, less than the actual speed of the car. So the equation underestimates in favor of the defendant. So if I charge someone with speeding, I say they were traveling at not less than 64 kilometers per hour, because I know there's a bit more braking happening here that I can't see and can't measure. So I hope that helps as I expect, because it's a very good question. Just remember, the speed calculated is the minimum speed. It is accurate to within 1 or 2 kilometers per hour. The more accurate your measurements for skid length and drag factor, the more accurate your answer will be. So I hope that helps.
Okay, we have one hand raised, but there is another question. I hope, Mark, you have this English translation on. The question from the chat box is, what if the road section is not flat but has some slope, needs some trigonometry? And I'm pretty sure that you are going to tell about this later, but of course you can quickly answer this question, and then we can ask from Azizbek his question.
Yeah, no, good question, and absolutely yes. When the surface is not flat, we have to account for the gradient, for the slope, and we will show you the mathematics to do that in 2 more slides. So basically, if you skid uphill, gravity is slowing you down as well, so you will stop shorter, so it increases your drag. Skidding downhill, gravity is trying to pull you along the hill, so a downhill skid effectively reduces the drag, but we'll show you how to adjust the drag factor to account for slope in 2 more slides. Very good question. Awesome.
Yeah, I see that Azizbek decided not to ask the question now. Okay, so if there are no questions.
No problem. I'll get my mouse.
Нет, я просто вас ждал.
He still wants to ask the question because he was just waiting for the previous speaker.
Okay, go ahead.
Алло. Значит, может ли повлиять неисправная тормозная система на тормозной путь?
If the braking mechanism is not in order, is broken, can it be the reason of wrong equation calculations?
Excellent.
For instance, the braking doesn't work properly.
Yep. Very good questions. And I'm glad they asked, because it's exactly what we will be covering as well. Yesterday, I talked about vehicle inspections to test the brakes. So the mechanic can tell us if the back brakes weren't working or the front brakes weren't working. We need to know that because it affects this equation. We have to adjust the drag factor to account for braking problems. So we will show you how to do that. Again, in a couple more slides, we've got a whole section on circumstances that you have to adjust your drag factor for slope, for brake inefficiency or braking problems, for vehicles towing trailers, things like that. So excellent question, Azizbek. If you bear with me, we will take you through how to deal with it in a couple more slides. So it shows me you guys are thinking ahead. Excellent. Alrighty. Let's do the last one here. Sorry, the second one. We'll just do the 2 because everyone knows how to do it now. This circumstance, we have 37 meters of skid mark. So D of 37, and we have a drag factor of 0.65. So we have F of 0.65. Let's put the maths through and see how fast we are going. With the equation, 2 times distance, 37, times gravity, always 9.81, times drag factor 0.65, 0.65. We get 471.86. We take the square root to get velocity, and our velocity there is 21.72 meters per second. We want speed, multiply by 3.6, and we have a speed of 78 kilometers per hour, and I hope that's right. Yes, awesome. So for that circumstance, vehicle leaves you 37 meters of visible, measurable skid mark. You've done skid tests, you know that the surface drag is 0.65. What you can say is the minimum speed for that vehicle at the start of skidding was 78 kilometers per hour. That's all the equation is. As I say, don't be put off by it looking complicated. Once you know what the symbols mean, it is what we call it plugging and chugging. Plug in the numbers, hit the equals, it chugs you out the answer. And that's how to do it. Right, that's the base slide to stop, skid to stop equation. Let's complicate it, because life is never simple. In real life, often a car will skid on different surfaces. So it may start its skid on the road and skid off the road onto grass. So now we have the problem. We have two different drag factors. We have a good high grip on the road and a less amount of grip, more slippery on the grass. So we need to have a way to deal with this. And what we do is called the combined speed equation. Because we are dealing with velocity, which can have a positive or negative value, so it can have a direction, it can be going forward or backwards. It's a vector. We can't simply add the distance. We can't say 10 meters on the road, 5 meters on the grass, we have a 15-meter skid, because we've got different drag factors. So what we have to do is calculate the speed for each surface. So we will do our slide to stop equation for the road, the 10-meter skid on road. We will then do our slide to stop equation for the 5-meter skid on grass, and we combine them using this equation here. So V1 is the velocity on surface 1, V2 is the velocity on surface 2. We can have as many surfaces as we need. We might have 4 different surfaces. So we'll have velocity on surface 1 squared, plus velocity on surface 2 squared, plus velocity on surface 3 squared, and so on and so on. Following the rules of maths, inside the brackets gets done first. That square is an operation. So the first thing we do is have our velocity, square it, plus velocity squared again. And as I say, the calculators are clever. They will do this for us. But we're going to do an example. You will have copies of these presentations. So these examples basically are worked through for you step by step within it. So you can use these as a reference to refresh your memory and practice it. But we'll go through. So this example, a vehicle skids for 15 meters on the road with a drag factor of 0.7. It then skids a further 7 meters on grass, and our drag factor on grass is 0.5. We want to know how fast it is traveling at the start of skidding. And a handy hint for these types of situations is draw a little picture. So we have a 15 meters on the road, and drag, excuse my writing, very hard with a mouse, 0.7, and we have a further 7 meters on grass at 0.5. So that's our situation. 15 meter skid on the tar seal, goes off the road, skids for another 7 meters on the grass. And as you can see here, we have the equation. We have to calculate the velocity for surface 1 on the road. We have to calculate the velocity for surface 2, the grass. We simply repeat that equation we've just been working through. So we'll quickly do it. Clear my system off. First one, 2 times 15 times 9.81 times 0.7 equals 206.01, which we've got there. If we take the square root, we get our velocity 14.35. We repeat the process for grass. So we have 2 times our skid length of 7 times gravity times our drag factor of 0.5 gives us the answer of 8.29 meters per second. So we now have velocity 1 for surface 1, velocity 2 for surface 2. Sorry, I've got an S instead of a V, but it is velocity. Now we're going to combine them using this equation. And ignore the S, it can be S, it can be V, because you can actually do this with speed as well, should you need to. But first one, velocity 1, 14.35 squared, plus velocity 2, 8.29 squared. We do that mathematics, we get 274.65. Take the square root, our velocity there, 16.57 meters per second. So converting that to kilometers per hour, we have 59 kilometers per hour. So in this circumstance, at the start of the first visible part of skidding that we can see, that vehicle was traveling at not less than 59 kilometers per hour. We've managed to deal with the two separate surfaces, the two different drag factors, and still arrived at our speed at the start here. That's what the combining speed equation does. So very important for different surfaces, because if the different surfaces have different drag factors, you have to account for that difference in drag. If you think a little bit on what we've just done, if we want to calculate the speed from a skid mark where a car has skidded and say hit a tree, so it hasn't skidded to a natural stop, it's had an impact at the end. We can nominate a speed for the impact with the tree. How do we do that? That's getting into advanced crash investigation. But a general rule for you, it's crush the amount of damage to the car is every inch that car is crushed in is 1 mile per hour. So if you have 12 inches of crush, that car is deformed 12 inches, it is a 12 mile per hour impact. We can convert miles per hour to kilometers per hour, and from there to meters per second, and that's our terminal speed. Then we do the speed for the skid leading up to it. So we've accounted for, we've got a speed estimation for a vehicle that's skidded and impacted with something. It's in that circumstance, it's very much an estimation because the reliability of your impact speed is a little questionable. So I've told you that trick just so it's something you can do to make an appraisal of speed. If it's coming out at a very high speed, start doing some more questioning of the motorist, of the driver. You can say, you know, I'm estimating your speed at 130 kilometers per hour based on the length of your skid and the damage to your car. They may well give you an admission of speed. The other way to deal with that situation, where a car skids and impacts with something, calculate the speed from the skid mark. We know it is going to be very much an underestimate, but you can say, based on the skid mark alone, the vehicle was traveling at whatever speed, 68 kilometers per hour. That does not include the speed absorbed during impact to cause the damage visible to the car. So you let the courts see a photograph of the damaged car and they will make their own impression. Until such a time as you get the further training in speed from crush, that's about all you can do. So that's how we combine speeds. Just remember, don't add them together. Use this equation here. Square the individual speeds, add them together, take the square root for your answer. All right, let's talk about incomplete braking to give some detailed answer to the question we were asked. First thing is, when a vehicle, a tyre, doesn't lock while braking, it's not going to leave a skid mark. If we don't have visible skid mark from all four tyres, we can't be sure that all four tyres were braking. we can't use the full coefficient of friction, the full drag factor. We have to adjust it to account for the fact that some of the wheels weren't braking. Your mechanical inspection is very important here. You need the mechanic to look at the vehicle and tell you that yes, all 4 brakes are operating correctly, or no, the rear brakes aren't functioning. You need to know that so we know how to adjust the drag factor. It's a lot to do with weight shift. We've talked about weight shift. When you brake, you feel yourself move forward, the weight shifts onto the front of the vehicle. And the vehicle ends up with the front wheels carrying about 60% of the mass and the back wheels, the rear wheels, 40. We use these numbers to determine how much brake force to apply. So the front left tyre, that's capable of 30% of your braking. The right front tyre, another 30%. So your front wheels will give you 60% of the braking capability of the vehicle. That means that if this car has left a skid and it's only the front brakes that are working, it's only been able to give you 60% of the possible braking. So it's only using 60% of the available drag factor. So we need to adjust it. And we have a term for adjusting the drag factor. Any number that we use to adjust the drag factor is called an N factor. And in this case here, we have a car that leaves a skid on a dry tar seal road. So drag factor, typically 0.7. We know the car only has front wheel brakes, so it is only giving us 60% braking. We adjust the drag factor by multiplying by that percentage. So 0.6 is the same as 60%. 0.6 times 0.7 gives us our adjusted drag factor, which is 0.42. Once we have that value, we then use our slide to stop equation, just a normal equation, but we've got this adjusted drag factor, which accounts for that lack of back brakes. If only one of the rear brakes wasn't working, we've taken out 20% of our braking. 100 minus 20 is 80. So our brake efficiency is now 80%, or 0.8 times the drag factor. It all depends on what your vehicle inspection, mechanical inspection discloses in terms of braking and are the brakes working or not. So we'll just quickly run through an example. Right, this circumstance here. A vehicle has left 37 meters of visible skid on a tar-sealed road surface. The mechanic inspects the car and he tells you that the rear brakes are not working. We want to know how fast the vehicle is traveling at the start of skidding. We've been made aware there is an issue with the brakes. We do not have complete braking. So we have to calculate an N factor. We have to adjust the drag factor. Rear brakes is 40% of the work, front brakes 60%. So we only have front brakes, so we only have 60% efficiency. We now need to do our adjustment. Dry tar seal road, drag factor is 0.7. Multiplied by 0.6, that's 60%. Gives us a drag factor of 0.42. Now we just use our standard slide to stop equation and do the mathematics. So we'll do that together here. And what do we got? 2 times 37 times gravity 9.81 times our adjusted drag factor, our reduced drag factor of 0.42. That's right, it hasn't picked up the decimal point. 0.42. Didn't pick it up somewhere. Damned mouse. 2 times 37 times 9.81 times 0.42304.89. We take the square root to get our velocity, 17.46 meters per second, times 3.6 equals 62 kilometers per hour. So the speed at the start of, the minimum speed at the start of visible skid marks in this case is 62 kilometers per hour. That includes adjusting for the fact the rear brakes aren't working. So that's how we deal with braking issues. We still use the equation. We just have to account for the issue by adjusting the drag factor. So I'm going to duck back a couple of slides. Sorry. I thought I had it done completely. It's all right. Ignore that. I was confusing myself. Yeah, so remember this process. Remember, for a car, 60-40 split front to rear. The same can be applied to other vehicles. Motorcycles, motorcycle braking, that is completely different. It can be huge, 80% on the front wheel. In some cases, 90%. So we use 80-20 as the front to rear split for motorcycles. With a motorcycle, if you go to a crash involving a motorcycle and you can see a skinny skid mark, what that skid mark looks like will give you the information on how much braking was performed. A rear-only skid from a motorcycle follows a lazy, weavy S-type path. So it's a bit like a long snaking path. And what that tells you is that it's rear wheel only braking. So we are only going to use 20% or 0.2 as our adjustment. If the motorcycle skid is, it is narrow, but it is straight, that indicates front braking has been applied. We can apply 100% braking. Motorcycles, the minute you brake hard and lock the front wheel, they will fall down. So you're not going to see very much front wheel only braking on a motorcycle. Most the training and most riders with experience will learn to apply the back brake and apply good firm pressure on the front, but not to the point of locking it up. So a clue for your braking too is have a look at the experience of your motorcycle rider. How long has this person been riding a motorcycle? Because it takes an amount of time, a year or two, to get the confidence to use the front brake of a motorcycle properly. Most of us as children who had push bikes experienced falling off by grabbing the front brake and pulling it on instantly and hard. You end up going over the handlebars and falling off. That's one of those lessons that sticks with you for a long time. And when you start riding motorcycles, the experience of the front brake causing you to fall, causing pain, is a hard one to overcome. So it does take time. Cars towing trailers, unbraked trailers. So this is done by the weights involved. So I have a 1,000 kilogram vehicle towing a 500 kilogram unbraked trailer. The car now has to stop itself plus the trailer. So because the trailer isn't doing any braking, it's asking the car to do it for it. So we have to adjust, and the trailer effectively pushes the car along. Because the trailer isn't being braked itself, it's trying to push the car. So it makes us skid longer. So we had to adjust the drag factor. And how we do it is the weight of the car divided by the total weight of the car and trailer. So car is 1,000 kilograms, car plus trailer is 1,500 kilograms. I'll quickly do the maths, divided by 1,500. It ends up with a adjusted drag factor of our N factor, our adjustment rate is 0.67. So their car weight divided by total weight equals 0.667, okay? That is what we then multiply the drag factor by. So dry tar sealed road, 0.7, times it by 0.7. We would use a drag factor of 0.46 to calculate the speed of the skid mark in that circumstance. So just remember, weight of the car divided by the total weight of car and trailer, that's your adjustment factor. Multiply your drag factor by that adjustment factor and use that in the mathematics. The last thing I want to talk about in terms of adjusting this adjustment is trucks. Heavy trucks, the tires are made from slightly different compounds of rubber. They're a lot harder than passenger car tires. And because they're harder, they don't quite grip the road as well. So they're a little bit more slippery. And from studies performed at crash testing situations around the world, we've determined that a truck tire will only give you 80% of the drag factor as compared to a car tire. So if you're measuring a truck skid, you have to adjust the drag factor by 80%. So multiply by 0.8 and use that adjusted value in your skid equation. That accounts for the difference in rubber compound of the tires on the truck. And let's get that one. The other question, as I say, they were fantastic questions because it's exactly what we need to think about. The effect of gradient or slope. Think about walking up a hill. It takes a lot more effort than walking on the flat because as you go up the hill, gravity is trying to hold you back down. So we're fighting gravity. Walking downhill, on the other hand, is easy because gravity is trying to pull us down the hill. So it's helping us along. And that impact of gravity applies equally to skid marks. How do we deal with it? We have to measure the slope of the road. So I'll just get a little pen on here. So we've got a road sloped up there and the car has left skid marks going up the hill. It's on tar seal, so we know we've basically got a drag factor of 0.7. What we need to do is measure the gradient or slope of that road and use that gradient to adjust our drag factor. How do we do that? Easiest way, and the way I've done it before, is download a spirit level app for your smartphone from the Google Store or Apple Store. There's free apps that turn your phone into a level. Once you've got that app, turn it on and place the phone on the road. So just lay your phone on the road surface and read what it says. They will generally report a gradient. You'll either see a value of something like 0.05 or 5%. Often they will give you the degrees as well, but we are interested in this grade, the value of the grade. What we do is use that to adjust the drag factor. In this case, it's not multiplication, it's addition or subtraction. So our road surface, 0.75, skidding uphill, gravity is adding resistance. So we add that grade to the drag factor. So for a tar seal road, uphill slope of 5% or a 0.05 gradient, the drag factor is 0.7 plus that grade. So it's 0.05, which means now our drag factor is 0.75. We've increased the drag factor to account for the fact that gravity is also slowing the car down. If the skid is downhill, it's the exact opposite. We subtract the gradient. So dry road, downhill skid, 0.7 minus 0.05 minus our gradient gives us a drag factor of 0.65. So it's slightly less than on a level road because gravity is helping to pull the car down the slope. So I hope that...
Минус 0,05 от коэффициента торможения. И мы Опять мы измеряем сначала при помощи приложения в смартфоне, которое можно загрузить в Play Market или других сайтах. Можно загрузить это приложение и применять уже на дороге и определить уклон, наклона вверх или вниз.
Skid testing to determine the actual drag factor for your surface. So up until now, we've just been using an estimated drag factor, and you can say that drag factor was taught to us by a crash investigator who has done 30 years of experience and has attended hundreds of crashes and done hundreds of skid tests. So there's a bit of validation to it, but best evidence for skid, sorry, we turn off my silly pen. Why is the equation not showing? I'm just going to have to put an equation on here. Sorry about this, the slide's missing a vital piece. And we'll see if we can paste it. Find the slide, there. Bear with me, sorry, I just want to make sure that we show you the equation, otherwise there's no point in doing any of this. Yeah. Hopefully that equation has popped up. Excellent. All right, back on track. What we have here is how to determine drag factor based on test skids. Now, safety is huge with this. Test skids is quite a dangerous activity because we are deliberately putting a car into a skid situation, so effectively putting it out of control. So first thing we need to do is protect the scene where we're going to do the skid test. We want to do the skid test at the scene because we want the drag factor of the road surface at our crash scene. It's the last thing you do before you leave the scene. We don't want to contaminate our scene with putting new tire marks in it. So complete your examination, complete your photography, complete your measurements. And before the other staff go, we keep that road closed and we will do our test skids. 50 kilometers per hour is a good speed. And what we do is we drive into our scene area at a constant 50 kilometers per hour. And we apply the brakes hard and fast, as hard as we possibly can. We try and push the brake pedal through the car. We want the tires to lock as quickly as possible. And we will hold the brake on all the way until the car stops. We can then move the car off and we measure that skid mark. We are trying to determine the value D for this equation. Think about our unknowns. We know gravity, the 2's always there. We've just measured our skid length and we know velocity. We did these tests at 50 kilometers per hour. So 50 divided by 3.6 gives us our 13.89 meter per second velocity. This is the equation we do. So I'm going to pop out a calculator again and we will actually work through it. Test skids. Actually, let me write some numbers on here so we know what we're talking about. Speed equals 50. Apologize for my writing. B equals 13.89 meters per second. D, let's say our test skid was 12.8 meters. So we did our test skid at 50 kilometers per hour. The velocity then is 13.89 divided by 3.6. We measured our skid mark at 12.8 meters. So now we know everything we need to calculate drag factor, which is what we're trying to do. It's the whole point of these test skids. We will use this equation. Drag factor is equal to the velocity squared divided by 2 times G times D. We have a bit of BODMASy stuff going on. So we do the brackets first. I'll get my calculator up. Clear everything. 2 times G, it is 9.81, always is, times D, the length of the skid that we just made, times 12.8 equals 251.136. I'm writing that down. Velocity squared, 13.89 squared. 13.89 squared. Oh, I didn't do my point, did I? 13.89 squared equals too many. I'm gonna, sorry, I put your crook. I'm going to do this.
You pressed the wrong one.
Yeah, yeah.
X
I'm going to do this
instead of x squared.
Yeah, silly boy. Easy. The calculator knows BODMAS. Let's just do this as it stands. 13.89 squared divided by, open brackets, 2 times 9.81 times our skid length, 12.8. I'm just hoping all of these are working. Close our bracket. Equals 0.76. That is the drag factor. So using that equation, based on the test skid speed that we know, so test skid 50 Ks, 13.89 meters per second. We measured our skid 12.8. We put those values into this equation and it gave us a drag factor of 0.76. So the drag factor for that road at our crash scene where we did our test skid is 0.76. That's the process. The only warning I give with it is to be super deliberately causing a skid, causing your vehicle to be out of control. I see a question.
Да, вы меня слышите? Значит, я просто слышал за рубежом, что
I heard that in other countries, on the crash, the scheme, there is some template with the scale 1 to 1, and you can. There is a frame which is put on the scheme of which is drawn on the crash site, and based on this template or frame which is put on this scheme, you can identify who is to fault.
Okay. Not something I've heard of. I have heard of templates. The templates I used to use, they came from American University, and it was a scale ruler, and it also had a way to calculate speed on it. So on my scale plan, I could put the template on the skid mark, and it would point to a speed based on those skid marks. But it didn't tell me who was at fault. It just gave me some information on the circumstances there. I would be very cautious of a template that claimed to tell you who was at fault. That's the investigator's role. You have to apply the laws of your country to the scenario that you have established has happened through your investigation. Yeah. So I hope that helps. Hey, that wraps up, concludes the mathematics part of this, this introduction to crash investigation. So I'll just stop sharing my screen. Hopefully that's worked. First off, fantastic questions asked through that the last 2 hours. It shows us that you are thinking deeply about how reliable the information is that we're giving you. So you're testing us, which is great. But it also shows that you're thinking about possible things you may be asked in the future when you start applying this work. So I hope the answers we've given you and the information we've shown you gives you the confidence to go and use this, these techniques to give you good, reliable speed estimations as part of your investigation. So before I hand to Arthur, I see we have a hand up. So let's, we have another question. Let's go to that.
Yeah, Mr. Erlan, go ahead.
You're on mute.
Алло, слышно, да?
No problem.
Согласно правилам дорожного движения нашей
According
республики,
to the traffic rules in our country, a driver who is moving and when he sees some risk, he should brake until full stop of the car. But in our practice, the public transport drivers, in order to avoid the passengers falling, they are not braking to full. And the question is, what is the way to identify whether the driver braked fully or not?
So many
Because
good questions.
They always say, and the reason for not braking to full is that they don't want the passengers to fall within the bus or within other public transport.
Yeah, completely understand that. Excellent question.
And therefore, on the roads, we cannot see the skid marks.
Yeah.
And then we have to conclude that they didn't take any measures in order to prevent a road accident. Did you get it?
Yep, excellent. Very good question. And yeah, what we have just worked through, we needed visible skid marks. So nice and easy. The circumstance where there aren't visible skid marks, so exactly that example, driver brakes, but only half brakes or quarter brakes to gently slow down. It is problematic unless we have the ability to download the computers in the cars. We can only guess, unfortunately. One of the annoying things with crash investigation is that many times we cannot get the answers we need. We just don't have the evidence, the reliable evidence on which to base our calculations and our assumptions. What we can say in that circumstance is that the bus is capable of stopping quickly. We could say if it's a dry road, drag factor 0.7, we can do the calculation to say the bus is capable of stopping in 20 meters at 50 kilometers per hour if it applied its full emergency braking. There is no mechanical fault with the bus, so it is capable of full braking. The driver has not applied the brakes as hard as he possibly could. And perhaps that is enough to convince the courts that the driver has been negligent in not stopping as hard as he could. Without a visible mark, very difficult. So all you can do is say the bus is capable of stopping in this distance. The bus had no fault with the brakes, so therefore the driver has not taken appropriate emergency action. I guess that's how I would deal with it. Arthur, anything from you?
Yeah, I totally agree. It is a problem, but in that situation, when having the bus full of passengers, we cannot underestimate the witnesses, because they can also testify how the situation was. But of course, coming back to technical issues, yeah, in Poland we also we are allowed to do kind of right test. It's a kind of experiment. Which we can always use as evidence in the case. Of course, we need a police officer who has this driving license for buses, because I didn't have, so I wasn't allowed to drive buses. I was allowed to drive passenger cars, and many times I did kind of experiment, because people were trying to cheat, that, oh, you know, the brakes were broken, and then we, of course, if it's possible, because if there are huge damages, it's impossible to drive a car, but if they are not so huge, you can drive a car. At least in my country, we as a police officers, we are allowed to do this kind of experiment test. This is, yeah, what we can add to this. Of course, during this test, you can use this device. We call it decelerometer, that checking how the car was slowing down. So yeah, there are some measures and kind of things we can do, but of course not in every accident we do this. Yeah, I hope that I answered that question.
Awesome. Cool. Hey, that pretty much concludes today's session and concludes the course. So Arthur, did you want to say anything before we hand back to Ritu? And I think we have someone who's going to talk to us to close the session today.
Before I thank you to our participants, just to remind, because I see that we have a lot of participants now, I've just sent you on your emails a link to the test. Remember to fill it, so you can find it easily on your email. It will display on your browser, and you go through the numbers, through the questions, and you will be done with that. So just kind reminder to do this. And yeah, before I give the floor to Ritu, I'd like to thank you for participating in that training. I hope, and I'm pretty sure that you will get at least some information from that training that you can use in your daily job. So even if you take one good solution or a good advice from Mark, because he was mainly the guy telling you the technical part, I think we have a success. So thank you once again. I want to thank you to Mark. I want to thank you to Ritu and all the people who contributed to this training. And yeah, I hopefully see you in the future face to face, because what I heard that there is a possibility that one day we can go together with Mark to your country to deliver this kind of training face to face, which is better, because then we can arrange kind of accident on the spot and then to do this in a more practical way. But since there is a COVID, so yeah, a lot of problems. Yeah. Okay, thank you very much. And Ritu, are you there? I think it's time for some closing speeches.
Yes. Thanks, Arthur. And thanks, Mark, as well. Yes, we are now close to our training. So we have a closing remarks from Stephen, who is unit head from Kyrgyz Resident Mission. So I would like to hand over the floor to Steve. Hi, Steve. Are you there?
Hi, Ritu. Can you hear me?
Yes, I can hear you.
Yep, fine.
Okay, good to see you again, Ritu. Yes, as she said, my name is Steve Lewis Workman. I'm the Deputy Country Director in ADB's Resident Mission Office here in Bishkek. I would like to thank you all for your participation in this important training course. This workshop was funded through ADB's Regional Technical Assistance Project, Enhancing Road Safety for CAREC member countries, and was designed specifically for professionals involved in crash investigation. Road crashes,
которые расследуют ДТП. ДТП – это шестая причина смертности в Центральной Азии по данным ВОЗ.
175 countries in road accident deaths. At present, the risk of dying on the roads in the Kyrgyz Republic is nearly 5 times that of the countries with the lowest rates in the world, such as Sweden, the United Kingdom, and the Netherlands. As the Kyrgyz Republic continues to develop its road network, the country will benefit from proactive road safety initiatives and better crash investigation processes. We at ADB hope to strengthen this capacity through technical assistance and training to enhance road safety in the Kyrgyz Republic and across the CAREC region. This course was designed to provide participants with additional knowledge to manage and understand traffic crash scenes. We hoped that you have gained some new insights into the methods and practices in crash investigation, gained more understanding of the causes of road crashes, and eventually to use the information to help reduce the number and severity of traffic crashes, which will benefit the people of the Kyrgyz Republic. In closing, on behalf of ADB's resident mission to the Kyrgyz Republic, I'd like to thank you all for your participation and wish you a productive and rewarding new year. Thank you very much.
Thank you, Steve.
Sorry, I was muted. Thank you, Steve. Thank you very much. And thank you for highlighting road safety, importance of road safety in, Central Asia and Kyrgyz Republic. Now, we are almost close to this session. Before closing, I would also like to thank everyone. First, I would like to begin with Mark and Arthur for delivering wonderful content with excellent energy in the bizarre times for you. I know it was for Arthur and you, it wasn't, usual working hours. So yeah, thank you very much. And today we have completed the 3 days of the training. I would like to take this opportunity to share with you that we are planning another workshop for Kyrgyz Republic, which would be regarding specific deterrence, where we would be more focusing on Kyrgyz Republic context as well, which is basically the 6th module of this workshop. So as we plan something, we'll definitely be in touch with you and let you know what's the contest, and we'll seek for your participation. And yeah, and I understand there's a lot of challenges in organizing a virtual training, and I would like to thank all who helped and made this online training a very successful one. I would also like to thank all the participants personally and on behalf of ADB as well. We very much appreciate your involvement, and thank you for sparing your valuable time for all the sessions, which took over 3 days, and especially your wonderful questions which were raised and your active engagement in the workshop.
Yeah.
We are hopeful that by participating in these sessions, you have gained useful knowledge and new ideas and skills to understand crashes. I understand some sessions were very technical, and it would have been more valuable if we had done it face-to-face. But as we all are aware that COVID situation, so online mode was chosen. And as I earlier said, please feel free to download the recording and documents and go through them if you want any more detailed information. And we will also send you the post-evaluation form. Please fill us and send your feedback so that we can improve anything if you feel that some improvement is required. Moreover, as I would also like to remind you on the online test, which Arthur already explained. So as you complete the online test, we'll be sending you the certificates of the attendance of this training. And yes, last but not the least, I would also like to thank the interpreters who help in translating and helping this training possible. And our ADB colleagues from KRM, Steve, Medin, Aidana, and from CWTC, Pilar, Marian, for your huge support and efforts to organize this training. And for participants, I would like to request that if you have any queries or you need any support from us, please let us know. So yeah, by saying this, I would like to end this training. Have a nice year ahead and take care.
Thank you very much. We have one participant, Yashkilik, would like to add something.
Please go ahead.
Yes, I would like to thank Mark and Arthur for their very responsible attitude in conducting this training, because they shared a lot of useful information with our inspectors, with militia officers. We would like to thank you for so much useful information, and I hope that we'll have a chance to meet physically in the future to be able to discuss these issues in detail regarding road crash investigation. Thank you very much.
Thank you.
The Ministry of Transport and Communications is also grateful to the ADB resident office for conducting this training. And it was 3-day training, and I would like to thank all organizers. I would also like to thank our participants, my colleagues, and representatives from the Ministry of Interior who were very active participating in the training, because I believe it was a very important training for our staff, and it was also interesting to us. Of course, online mode has its own constraints or challenges, but we do hope that in the future we'll have similar trainings, workshops in the offline mode. Of course, this depends on the situation with the COVID, and I do hope that we'll have such opportunities. Now I'd like to wish you very good health. Please take care of yourself, and I wish success in all your work, and great success to all representatives of ADB. Please don't forget about Kyrgyzstan. Thank you.
Excellent. Brilliant. Cool.
So yeah, so let's end this training. Thank you all. Thank you so much. Bye-bye.
Thank you.
Thank you, everyone. Hopefully we see you soon in person. Bye-bye.
Bye-bye.